Okay, let's consider the rule of three for the list class. Up until now, I haven't implemented any of these functions. And so that would be the rule of zero. I decided to do nothing. But what should I do? Is this the rule of three or the rule of zero? Just to refresh your memory, the rule of three says we should either implement all of the copy constructor, assignment operator, and destructor, or none of them. So what should we do? Well, without too much thinking, hopefully you can remember that, well, we have a head and a tail pointer that are pointing to nodes out in memory. And those are things we allocated with new. And so at a minimum, when we run our destructor, if there's still things in our list, if our list is not empty, we need to destruct them. We need to destroy them, right? And since we need to implement the destructor, that means we need to think about the implementation of all of them. We need to follow the rule of three, implement the destructor, implement the copy constructor, and implement the assignment operator. Well, the destructor is pretty simple. And in fact, I pretty much showed this to you in a previous video where we were writing some, or looking at the full implementation of the list. So what do we need to do when we destruct this list? Well, we just need to remove everything from the list. And we already have a function that does removal for us. And so what we can do is just write a little while loop that says, while the list is not empty, remove the next item from the list. And we wrote this, in fact, we can make this code even a little bit shorter by embedding remove here. But once we've removed everything, the head and tail will become null and empty will return true, and that'll stop the loop. And remove was written very carefully to make sure we properly deallocate memory. So for our destructor, we're able to take advantage of our member functions and make this code pretty simple. What about the other member functions? How should they work? In particular, when we talk about the copy constructor, we have to come back to that question that we looked at in week 2, and that is, do we want a deep copy or a shallow copy? And it kind of boils down to this. Like if I make a list, let's call it mom's list with milk, eggs, and bread, and then I make a copy of mom's list and append all the junk food to it, then am I going to have my own list that includes everything on mom's list plus junk food? Or am I actually adding junk food to both of our lists, to both my list and mom's list, right? So if I do a shallow copy, then the head and tail pointers are just going to get copied over to the new object. It doesn't say anything about the things they're pointing to, right? Shallow copy doesn't care what head and tail are pointing to. It just copies head and tail. And so that means my copy would look like this. And it would be pointing to the same milk node and the same bread node that's in mom's list. So if I then used copy to append to this list, then it's going to modify bread to point to all the junk food that I just added. And actually, it also creates some subtle bugs in the process. And that would be bad, right? This shallow copy would actually be quite bad. This is not what I want. When I make a copy of the list, I want it to be my own unique list. What I want is down here. I want a deep copy. I want my list to now have my own milk, my own eggs, my own bread, and then I can add my own junk food here at the end. And, on top for all, in addition to all those reasons, maybe I don't want my mom to see the junk food that I added to my list. I want a deep copy, right? That's what I want to have happen in the copy constructor. So how do we make a deep copy happen? Well, we need to declare our copy constructor, in the suitable form. So remember, it's a constructor. That means the name of the function is the same as the name of the class. So it's just called list. And then we pass in a reference to the thing we're copying. And my standard way of doing that is calling it other. I'm copying from some other object. And then I'm going to make my object match that other object. And so I start off by setting head and tail to null. And then what I'm going to do is get a pointer to the head of the other list, loop over all of the nodes in that other list one at a time. And then as I visit each node in that list, I append the item in that list into this list, right? So, and I can achieve that just by calling the append function and getting the item out of the node in the other list. So temp arrow item, temp is a list node pointer, and since it's a pointer, I need to use the arrow operator. And then the item is the, the data that's being stored in that node in the other list. And so just by saying append temp arrow item, it's sticking that item into my list now. And then this temp equals temp arrow next, that's part of our standard traversal code that moves temp down one item in the list. And so this while loop will loop through the other list, appending each of its items one by one into my list. And when this code is done, the list that I'm creating will be a complete replica with all of its own nodes and all of its own copies of the data that's in the other list. And that's definitely what I want to have happen in my copy constructor. Okay, now for the rule of three, we should implement the destructor, copy constructor, and assignment operator. And we decided that we had to have a destructor, and that was pretty easy to do. We could just loop over all the nodes and remove them one by one using the empty and remove functions. For the copy constructor, I needed to traverse over all the nodes in order to make a deep copy and append them one at a time into the new list. Okay, but I actually didn't just show you what the assignment operator would look like here. But the assignment operator is really similar to the copy constructor and how it has to copy the content over. But the other thing you'd have to do in the assignment operator is remember to delete anything currently in the list, right? Because when you assign, you have an existing list and now you're changing it to match the list you're assigning it to. So first, we'd have to remove everything, then we'd have to add everything. It's not hard code to write. It's just kind of like a concatenation of the destructor code plus the copy constructor code. But I'm not going to show you that. Instead, I'll leave it to you as an exercise, probably come back to it on a homework, allow you to build that for yourself.